All right, class, today we're going to start Unit 7, Section 5, and we're talking about factor, perfect square, trinomials. All right, a trinomial is a perfect square if it follows this equation, where your first term is squared, your second term is 2ab, and then your last term is squared. All right, so what does this mean? The first and last terms are perfect squares. A is a perfect square, B is a perfect square. Remember, perfect squares are like 4, 9, 25. Okay, the middle term is 2 times one of the first factors and one of the second factors. So let's look at this. Okay, so if we were to factor this out, we would get a plus b, which is a plus b squared. All right, now let's double check and make sure we're right here. Let's FOIL this. So we have a squared, ab, b squared. This, once you combine your two like terms there, is equivalent to this. So when we factor that out, if our first term is a perfect square, our last term is a perfect square, and our middle term is 2 times one factor of the first term and of the second term, or the last term, we know that it's a plus b squared. Okay? You can also do it with subtraction. Okay? So, I have perfect square, 2 times my a and my b. So I know my answer is going to be this, which is a minus b squared. Okay, let's factor it out. A times a squared. A times a negative b times an a is a negative 2ab. And then a negative b times a negative b, that should be a positive b squared. Okay? So on perfect squares, you have to have a positive perfect square for that last term. Okay, so let's look at one with coefficients instead of variables, okay? Can we follow the perfect square with this trinomial? Well, we have 9x squared. Is that a perfect square? Yes. We have 4. Is that a perfect square? Yes. So, our a is 3x, because 9x squared is 3 times 3x times x. So you pull out that 3x, okay? Our b is 2. So then our middle term here should be 2 times a, which is 3x, times b. 2 times 3 is 6, times 2 is 12, 12x. So I know that I'm right here, okay? So what I can do is I can write my equation. I've identified what a is. Okay, so a is 3x, b is 2. So in simplest form, that is 3x plus 2 squared. Okay, y'all ready to try some of this? Okay, so in order for the perfect square to work, that has to be positive. It is. Check. 81x squared. Is that a perfect square? Yes, because 9x times 9x is 81x squared. 25. Is that a perfect square? Yes. 5 times 5 is 25. Now let's look at this 90x. We need that to equal 2 times a times b. Well, 2 times 5 is 10. 10 times 9 is 90, 90x. So here's our a, and here's our b. So my answer is going to be 9x plus 5 squared. let's check. Let's always check and make sure we're right here, okay? So let's FOIL this. Nine x times 9x, 81x squared. 9x times 5 is 45x. 5 times 9x, 45x. 5 times 5, 25. When we simplify that, we get 90x. And it is equivalent to this. Okay, let's do another one here. All right, so is x squared a perfect square? Yes. So that's our a. Remember, because you have a squared plus 2ab plus b squared. Okay? Our last one, 4, is 4 a perfect square? Yes. 2, that is our b. So then for our second term, we need that to equal 2 times a, which is x, times b, which is 2. So 2x times 2 is 4x. So this is a perfect square. So I know my answer is a plus b squared. All right, now let's check this and make sure we're right. X squared times x, x times x squared. X times 2, 2x. 2 times x, 2x. 2 times 2, 4. X squared plus 4x plus 4, and we're correct. All right, let's look at number 3 here. Now, is this a perfect square? Well, 9 is, and x is. Yes. Okay. Is 64 a perfect square? 8 times 8. Yes. So then for our middle term, what we need the negative 15x to equal. Let's just put 15x there. 15x to equal, we need that to equal 2 times our a times our b. Remember, that's 2ab. Well, 2 times 3 is 6. 6 times 8 is not 15. Okay? Therefore, this is not a perfect square. Now, let's talk about this for a minute, class. We had a positive perfect square for our last term. And our first term was a perfect square. The issue here was our second term did not match the 2ab. So it's not a perfect square. You cannot factor it that way. Okay? All right, let's look at 4. Is x squared a perfect square? Yes. And pull out an x. So there's our a. Is 49 a perfect square? Yes. 7 times 7. So there's our b. So then for our second one there, we have, what is that, 14x. That needs to equal our 2 times our a times our b. 2 times 7, 14x equals 14x. Check. So then, it's our a, let's put our number there. It's our a, which is our variable x. And it is our b, which is 7. Okay, now, something's different with this one because this one is negative instead of positive like the other one. So if we go back to the first screen, it's going to be this one right here. So when your second term is a negative coefficient, negative 2 instead of positive 2, that's where you have the negative in your perfect square. When the second term is a positive 2, that's where you have your positive, okay? So what this is going to be, it's going to be a negative. So So here's my answer. Now, let's FOIL it and make sure we're right here. You can always go back and check your answer. So, x times x, x squared. X times negative 7, negative 7. Negative 7 times x, negative 7x. Negative 7 times negative 7 is a positive 49. So x squared minus 14x plus 49, which checks out with what we started with. Okay, let's quickly get through these last two before I stop for the second round. All right, 9x squared, is that a perfect square? Yes. 9 is 3, x squared is x. 4, is that a perfect square? Yes. 6x, we need that to equal 2 times our a. Remember, there's our a and there's our b, times our b. So we have 2 times 3x, which is 6x, but then we have to times that by our b, which gives us 12x. That does not give us 6x. So this is not a perfect square, because that is not true. Okay, now let's look at number 6 here. For our first term, 36x squared, is that a perfect square? Yes. You can pull out 6x, so there's our a. For our last term, we have 14. Now, is 14 a perfect square? It's not. So, you can go ahead and stop here and say not a perfect square. All right, I'm going to need to stop before we go to difference of two squares and do a second part. So I'll see you in just a minute.